Okay, so this is lesson 7.3. We're going to be looking at absolute value equations and inequalities. All right, so some information. So before we can discuss an absolute value, the absolute value function, which is p of x equals this symbol right here, it means absolute value. You need to first understand what this symbol means. What does it mean? Okay, absolute value symbol means the distance between. So when you see that the absolute value of x, that means the distance between a number x and 0, because the absolute value of x is equal to x minus 0. So the distance between these two numbers, whatever that number is. Okay, and because this is a distance, this is why the absolute value is always positive, because it represents a distance. So this is one way to look at absolute value. As a function, p of x equals absolute value of x means that the y value is equal to the distance an x value is from 0. So this y value is equal to the distance x, this number is from 0. Okay, and so this gives us our parent function. This is a function that all absolute values are related to, and I'm going to go ahead and show it to you some characteristics about it. So the absolute value is a V-shaped graph. It has a corner. That corner is called the vertex. Okay, just like the quadratic equation, it's a lot of similarities are in the absolute value. Although this is a V shape, the quadratic is a U-shaped looking graph. It also has a vertex, which will be in the middle. Okay, and it is symmetric on a vertical line that goes through the vertex. Here is a vertex form of an absolute value. Look at it, it's very similar to the quadratic. H and K are also the vertex, so if you have it in this form, you can see that. A, also just like in the quadratic, A is determining if this thing is wide or narrow. So if A is a big number, it's going to be very narrow, and if it's a small number between 0 and 1, like a fraction like 1/2, it's going to be wider. If A is negative, then it will flip over the x-axis. So all the characteristics that we've learned in the quadratic realm also applies in this one. So the first thing you want to do in graphing an absolute value function is you want to find the vertex. So I'm going to walk you through this. I'll lay it out for you, and then I'll show you an example. Here's what we're going to do. We're going to find the vertex. We're going to make a table with the vertex in the middle. Then we're going to pick two numbers above that number and two numbers below. We're going to graph that table. We're going to label the vertex and 1 point on each branch. And we also want to name the absolute value equation if we need to. Okay, so let's go do an example of that. I have one set up right here. We're going to graph y equals 2 times the absolute value of x plus 3, then minus 1. So our first step here is to find the vertex. So where would the vertex be? So the same thing for the quadratic equation when it was in vertex form is the same process we do here. Take everything that's in the parentheses, in these absolute values right here, take it all, set it equal to 0, and solve for the x. When you solve for this, subtracting 3, we get x equals -3. And so this x equals -3 is actually the equation of the symmetry line that goes through the vertex. But also this number right here, -3, is the x coordinate of your vertex. So when you make a table of values, this number is going to go right in the middle. That is the vertex, the x coordinate of the vertex, and you're going to pick two numbers above and two numbers below. And you can pick any numbers that you want. Usually I just pick the next two going up and the next two going down. Okay? Now, where is the y-coordinate of the vertex? This is where the vertex is. I'm going to put a little b there so I know that's the vertex. Well, it's that number right there. So our vertex is at -1. So there's the vertex, -3, -1. And then as we go through this, kind of keep an eye out for the patterns that you're going to notice. Okay, so if we plug in -2, a -2 plus 3 is a 1. Okay, and so this will be 1, absolute value of which is 1. 1 times 2 is 2. 2 minus 1 is 1. Plug in a -1 in here. A -1 plus 3 is 2. The absolute value of 2 is 2. 2 times 2 is 4. 4 minus 1 is 3. And let's look at the -4. You'll notice on the -4, -4 plus 3 is -1. The absolute value of -1 is 1. 1 times 2 is 2. 2 minus 1 is 1. You'll notice that we're going to see this right here. We kind of predict this right here to be a 3. -5 plus 3 is -2. The absolute value makes that a +2. 2 times 2 is 4. Minus 1 is 3. Okay, so we graph all this stuff. I put the vertex in, -3, -1. -2 goes to 1. -1 goes to 3. And this side is a mirror image of it. It's to 3. I can do another point if I want, but I can also see a pattern. Since I know it's a V shape, that this right here, we can see that we're going to have this side right here is a slope of 2, so it's up 2 over 1, up 2 over 1. I can do it again, up 2 over 1. I know that's another point. And then whatever I need to do to help me draw this graph, make sure you remember that it is a V shape. Okay, a V shape. And then we do this side over here, a V shape. Make sure you put arrows on the end. Label the vertex, -3, -1. And then 1 point on each side. So since I have this one, 0, 5. And then I can use this one right here, which is -5, 3. You can use any point you want on either side. It doesn't matter. And because my graph is with my equation, I don't need to list it. If I had my equation in one paper and my graph on another paper, I definitely want to make sure that I put the equation that I graphed right up here at the corner. Okay, so this graph here would be done. That's how you graph an absolute value equation. Okay, so let's look at this absolute value stuff as equations now. So we're going to look at it and we're going to see what this means in this fashion. So let's take a look right here. So we're going to change things. We're going to look at this equation now. So I showed you how to graph an absolute value, but now I'm going to look at it as an absolute value equation. Notice there is no y anymore. What does this equation here mean graphically? So I want you to think back to when we did this back in, or something similar to this back in when we were solving linear equations. Okay. What we do is we want to look at it just like we did for solving linear equations. This here means that for what values of x will the graph have a y value of 3? Okay, so let's take a look at it. So graphical, so remember we take this side over here, we graph y equals absolute value and y equals 3, and we look at that. I'm just going to show you this graph. And then when we graph it, there's the absolute value, and then a horizontal line at 3, and you'll notice that it intersects in 2 different locations. One of which is at -3, and another one is at +3. Because the absolute value of +3 is 3, and the absolute value of -3 is 3, because that's how far those numbers are from 0. These two numbers are 3 units away from 0, and so that's why they're both going to be solutions. Okay? Where the graphs intersect would be solutions, and notice there's more than one. Okay? Well, we can't be graphing all the time, so That's what's happening when you look at an absolute value equation. So how do I solve it algebraically? Okay, so let's take a look at this. I'm going to lay out the rules for you that we're going to follow, and then we'll do some examples together. Okay, so here's what you're going to do. You want to isolate the absolute value expression. So whatever, this is the absolute value expression right here. You need to make sure that there's nothing out in front and nothing being added behind it or in front of it or anything like that. You just want to have a clean absolute value expression equal to some number. Okay? Absolute value expressions must be positive. So if you get this right here to equal a negative number, well, then you know that you have no solution. There's no way an absolute value expression is going to be a negative value. Now, the number you plug in could be negative, but the absolute value expression cannot be negative. So if that happens, you know you don't have a solution. But what do we do if it's not negative? Well, what we need to do is we need to split the absolute value equation into one positive equation and one negative equation. And then we're going to drop the absolute value symbols at that time. Because, just like we showed up here, two different answers, a positive answer and a negative answer, produce the same result. Okay? And so this answer right here could be positive, whatever that is, and this thing right here could be negative, whatever that is. And so that's how you split your absolute value inequality into two different ones. So you're going to have two equations now. You're going to solve each one for x, and those will be your solutions for the original one. So let's take a look at an example I'm going to do for you. We're going to solve this example right here. I'm going to give you 2 absolute value of 5, x plus 5 minus 3 equals 7. So we're going to do that problem right there. So our goal is to isolate this right here is the absolute value expression. So the 3 and the 2 are going to have to be removed from the side. So add 3 to both sides. And now I have 2 times absolute value of x plus 5 equals 10. You want to get rid of the 2, so if I multiply both sides by its reciprocal, which is 1/2, then I get the absolute value of x plus 5 equals 5. And so now I need to split this absolute value into two equations. So the first one is drop the absolute value, and you get a positive answer. Then you can drop the absolute value again, and then the answer could also be negative. So this number here will be positive, and then one will be negative, just like that. Okay? Solve each of these things. So x equals 0, or x equals, again, subtract the 5, negative 10. And you can take both these answers into here, and you'll see that you're going to get a true statement. And then those are your two solutions. Okay? So let's take a look at something else now. That is the absolute value equation. The absolute value equation. So now we're going to go one step beyond that. What does that mean? What does the absolute value of x less than or equal to 3 mean? Now I have an inequality. Okay? What's going on there? Well, this idea is basically the same as with linear inequalities. Okay? We want to know all the values of this that are less than or equal to a 3. Okay? So I have a little visual here we're going to look at. Okay? We're going to graph this out. Right? And so just like before, so if we have the absolute value of x is less than or equal to 3, we're going to graph y equals the absolute value of x, which is what I have drawn right here. And then we're going to graph the boundary line y equals 3. Okay? And when I do that, just like from the other picture that we had, okay, so this right here is y equals 3. Okay, there's the two intersecting points at 3 and negative 3. Okay, so what's going on here? What am I asking you to do? What does this mean? I want all the y values on the absolute value to be less than 3. Well, 3 is right here, and here's the absolute value. Where's all the y values? Well, the y values are the graph itself. So I'm looking for the values that are below this line. I'm looking for these things right here. Those and those. This is the part of the graph that is below the 3 line. Okay? And so that is going to be my solution. Since I want to know all the y values that are less than or equal to 3 in this picture, here's the 3. All the y values are from here downward are below. Okay? And so I need the answers between -3 and 3 because those are the ones that are below the line y equals 3. And so here's what you end up with. I'm going to lay it over here so you guys can kind of pause it and write this all out. And so here's this thing I just got done talking about. Let me line it up for you. So you can make note of it. And then we have this solution graph down here at the bottom. Okay, so here's our picture. Some things to look at. So for this equation right here, there are two solutions at -3 and 3. These are what's going to become called boundary points in your inequality. How many solutions are there for this inequality right here? Well, there's an infinite number of them because there's a bunch of y values in between 0 and 3. We need to know where those solutions are. Okay. When is the graph of y equals the absolute value of x below the line y equals 3? And we can see that it's below from here to here. From the x-axis from -3 to 3, the absolute value of x is below the line y equals 3. So all the x's below 3 and all the x's above -3, all the x's below 3 and all the x's above -3 are part of my answer. These are boundary points. When we do inequalities, here's something you need to remember about the symbols. Okay, if you have the symbol that is less than or equal to or greater than or equal to, that means the endpoint is going to get what's called a dot, and that means that point is included in your answer. If I have these symbols right here, you're going to put an open circle as an endpoint, and that means that the endpoint or the boundary point is not part of the answer. You can write it this way, or you can write it combined this way. All the x's between -3 and 3. That's how you would read that. And then you have a single variable solution graph, because we're not going to do this all the time. Okay, we're going to solve these algebraically, and then we need to write it as a single variable number line graph solution. So we shade all the points in between -3 and 3, which corresponds to what we see up here. So this is what we're going to be doing. Okay, this is what's happening. So let's do some examples algebraically. Okay, and then I'll go ahead and show you what we're going to do, and then we'll do a couple of examples. All right, so let me move this out of the way. It seems to be in the way. Nope. All right, so how do I solve these things? So just like for the equation, here I just use this symbol it could be any one of the 4 symbols. This is just here as a placeholder kind of thing. We want to isolate the absolute value expression. So just like this, we want to have this, then an inequality, and then some number. We're going to split it. Okay? We're going to split the inequality. Now, here's where it gets a little tricky. Okay? If I have these two symbols, see how they both are less than symbols. If that's the symbol being used, you're going to put an and in between. And that's going to mean that your answer is going to be between. But if I have these two symbols, one of these two symbols, you're going to put an or in between when you split it. And that means you're going to have answers that are going to be outside. It's going to be split. It's going to be over here or it's over here. So that's what those are going to be. So be aware of that. Okay. Don't forget the rule. Okay. Now take a look at this. Y, when I split it this time, notice that the symbol changed directions on the negative one. Why is that? Because remember, the answer, this thing here can be either positive or negative, correct? Since it can be positive or negative, when it's the negative one, this number here would be a negative thing, okay? It can either be positive or negative. When it's positive, it's just simply that. When it's negative, it looks like this. It's a negative of that, which is less than C. Well, I don't want to, so I can divide or multiply both sides by -1. And when I do that, don't forget the rule. When you multiply or divide both sides of an inequality by a negative number, you must change the direction of the inequality symbol. So that's what's happening. To keep these two pieces right here, this side, looking the same, we are assuming, or we are actually going through the process of dividing or multiplying by that -1 right out of the gate. Okay, so you don't even see it over here. Okay, it's supposed to look like that. Then you divide by -1 and you get that. So we're kind of like doing it all in one step. So that's why you're doing what you're doing. Okay, so we're going to split it according to these little rules, solve each of these inequalities for x, and then we're going to write our solution intervals and draw the single variable number line. Okay, so that's what we're going to do. Let's do some examples and then help you see how to do this. So here's the first example I want to look at. We're going to do the absolute value of 3x minus 6 is greater than or equal to 9. Okay? So remember, we want to isolate the absolute value expression, which in this case it is already done. There is no number being multiplied or added or subtracted in this thing, so we're good right here. So we're going to take this, we're going to write this value, 3x minus 6, is greater than or equal to 9. Okay, so we just drop the absolute values, write it as you see it. Because of that symbol right there, we're going to put or, and then we're going to put that expression again, 3x minus 6. This time we're going to change the direction of the symbol and make that a negative, less than or equal to -9. So that's how that works. We solve each of these things here for x. Keep in mind that if I ever multiply or divide by a negative, see right now I'm dividing, but it's not a negative, so the symbol stays going in the same direction. So there's that piece. Now we do this one, add the 6. I'll get 3x is less than or equal to -3. Then I'm going to divide by +3. See, I'm still dividing by a positive. I'm not dividing by negative. Even though that might be negative, we don't change the direction. Only the number you're dividing by. If that was negative, I would change the symbol, but I'm not. So this is now going to be less than or equal to -1. Okay? I usually like to rearrange it so that the numbers are in increasing order. So since this one right here is negative, I would put it before this one. So I would rewrite my solution would be x is less than or equal to -1, or x is greater than or equal to 5. That's my solution. Okay. And then we want to draw the number line associated with this. So here's -1, here's 5. It doesn't have to be in any, it can just be just like this. It doesn't have to be to scale or anything like that. These symbols right here mean that I'm putting a dot as my boundary, and all the x is less than -1, and a dot at 5, and all the x is bigger than 5. So that is my solution graph. There's my solution, and that is the first example. Let's look at another example. This time we're going to solve. And again, I wanted to show you one that is like this. Again, if there was any numbers outside or behind it or what, this absolute value, we'd have to move them first. Keeping in mind the rule about dividing or multiplying by negative. But I don't have that, so I can just go ahead and split this apart. I got 4x minus 12 is less than 20, so you just drop the absolute value and write it as you see it. That's the first one. That symbol going in that direction means I'm going to write the word and in between. Then I'm going to write the negative version of this, which means it's going to be that quantity right there, is greater than negative 20. Change the symbol and change the sign. Okay? Because you're basically doing this and you're multiplying both sides by a negative. Okay? So this thing here would be the negative answer. So there'd be a negative in front of that, and you're just dividing by that negative. Solve each of these individual equations. So we're going to add 12. We got 4x is less than 32. Dividing by 4, x is less than 8. And again, so you got 4x is greater than negative 8. Divide by 4, and so x is greater than negative 2. So x is greater than negative 2, but less than 8. So then the and means we're in between. So you can rewrite it and as this way, again, putting the negatives first. So x is greater than negative 2, and x is less than 8. This is one way to write it. If you write it that way, you're fine. If you put it together, because it's an and, you can put it together. Only ands can go together. You can write it like that. So this would be your solution, or this would be the solution, either way you write it. And then we want to do our solution graph. Here's negative 2, here's 8. These symbols indicate that they are not included, so we put open circles on the boundary points, and it's all the x's between those two values. So that is how you would write that solution. Okay? So there you go. If you have any questions, make sure to bring them up in class time, and we'll do more examples then.